Hi, my name is Meghan Kwartler, and I'll be your instructor for the SQL Server course. Get ready to expand your data science skills in SQL Server. You will write temporal EDA queries with SQL date functions, then apply modular programming techniques, and make your queries run faster by creating your own user-defined functions and store procedures. You will build on your skills acquired in DataCamp's SQL courses listed in the prerequisites. Please review them if they are unfamiliar. We will use real-world transactional datasets in this course, CaptialBikeShare and YellowTripTaxi. They contain transactions from rides of the BikeShare program in Washington, D.C., and yellow taxis in NYC. Transactional datasets exist throughout industries, so you will be able to apply the concepts learned in this course to your own data science projects. As you may know from working in Python or R, EDA is an iterative process where there is no set of questions applicable to all datasets. It's helpful to get curious about the data. Think of it like a book report, but you can't read the whole book. What stories can the dataset tell you? If you don't look for trends and anomalies first, you could spend time on rework later. You don't want to discover an unexplained outlier during a presentation to your peers or leaders. EDA is worth the initial effort. Working with date-time data in SQL is often less flexible than Python or R. This can cause beginners frustration, but you will feel confident in your ability to manipulate SQL date-time data once you learn the correct tools. Let's start with the convert function. It can be used with lots of data types, but it's very helpful with dates. We will only use the required parameters marked with parentheses and not the optional ones with square brackets. Three more helpful functions are datePart, dateName, and dateDiff. They require a datePart parameter to be passed, and the valid values are listed at the bottom of the slide. DatePart and dateDiff return integers, but dateName returns an nvarchar data type. Let's use these functions with our YellowTripTaxi dataset. The pickup date column is a date-time data type. It's great to have detail, but how can we summarize? The convert function can be used to convert date-time to a date data type. What are the busiest times of day in this dataset? Here we use the datePart function to select the top 3 busiest hours for the taxi pickups. Pass hour as the datePart parameter with the datePart function. Include it in the group by clause and count the number of records with the same pickup date hour value. Count ID in the order by clause returns the top 3 hours with the most number of rides. Which days of the week have the most revenue? DateName returns language about the date time passed. This query selects and groups the transactions by the day of the week. We can use sum to add all of the fare values together based on their day of the week, and find the top 3 by including sum in the order by clause. I wonder what the average ride length for Sunday is. We can use dateDiff to find the difference in seconds between the pickup date and drop-off date. Then convert to minutes by dividing by 60, and finally calling the average function. This query shows you how to use the dateName function in the where clause to only include the transactions picked up on Sunday. What stories can you learn from the BikeShare dataset?